All right, welcome back to the deep dive. Today we're going deep on this really interesting paper. It's called LLM-based Corroborating and Refuting Evidence Retrieval for Scientific Claim Verification.
Sounds like a mouthful.
It is, but it's a fascinating topic and super relevant, given all the buzz around large language models these days.
Yeah, definitely. I mean, LLMs are everywhere now, but there's this underlying concern about their accuracy.
Right. They're great at generating text, but sometimes they just make stuff up, like completely hallucinate facts. And that's a huge problem if we want to use them for, actual scientific research.
Especially in science. Imagine relying on an LLM to, analyze clinical trial data or something. The stakes are so high there.
Exactly. So this paper is all about trying to make LLMs more reliable when it comes to actually verifying scientific claims, making sure they're grounded in real evidence. And it's called CIBER. CIBER stands for Claim Investigation Based on Evidence Retrieval.
Catchy. So CIBER, huh? What's the big idea here?
So it builds on this idea of retrieval-augmented generation.
Yeah.
Archaeology. Are you familiar with that?
Well, yeah, argate. That's where you basically give an LLM access to a ton of external information, right? Like a giant database of knowledge.
Yeah, exactly. So it's not just relying on what it's already been trained on. It can actually pull in relevant info to, back up its claims.
Makes sense. So how does CIBER take that further?
Okay. So imagine you have a scientific claim, right? Something like vaccines cause autism, which we know is false.
Right.
But you want to see how an LLM would evaluate that. So with CIBER, you don't just ask it once. You ask it multiple times, phrasing the question in slightly different ways.
Interesting. So kind of like you're testing its consistency.
Yeah, exactly.
Right.
If it gives wildly different answers depending on how you phrase the question, there's some uncertainty there. It's not truly understanding the evidence.
Ah, I see. So it's like grilling a witness in a courtroom. Different angles, see if the story holds up.
Yeah, kind of. And the cool thing is, you don't need to know how the LM works internally to do this. It's a black box approach. So even with these super complex proprietary models, you can still assess their reliability this way.
That's a huge advantage. I mean, a lot of the most powerful LLMs are super secret, right? You can't just peek under the hood.
Exactly. And another advantage is that it's unsupervised. You don't need labeled data for each specific scientific domain. It's a general approach. So it could potentially work for anything from, physics to psychology to, archaeology.
That's pretty impressive. So how does it actually stack up against traditional RAG? Does it actually work better?
That's the best part. The paper actually shows that CIBER consistently outperforms standard RAG when it comes to scientific claim verification.
Really? That's fantastic.
Yeah. So it seems like this multi-angle interrogation strategy, it really does make a difference. All right, so let's dive a little deeper into the paper itself. They start off, as you might expect, by talking about, the rise of LLMs, all the amazing things they can do. But they also acknowledge this problem of hallucination.
Right. Got to keep it real.
Yeah. And they talk about how RAG is a great step forward, but it's not perfect. LLMs can still struggle with irrelevant info or rejecting valid info or just not integrating information from different sources very well.
Makes sense. So CIBER is trying to address those limitations specifically for scientific claims.
Yeah. And they're really focused on this idea of finding both corroborating and refuting evidence. Not just does this paper support the claim, but also does it contradict it?
Ah, that's smart. Because a single paper might not tell the whole story, right?
Exactly. So they want CIBER to provide a more holistic assessment, and they actually outline the whole process step by step. First, it retrieves relevant publications, then it evaluates the claim against them using these multi-faceted interrogations, then it spits out a verdict, like support, refute, or neutral, and a confidence score. And it even highlights the key papers that were most influential in, swaying the decision.
Oh, wow. So it actually shows its work, so to speak.
Yeah, kind of. And that's really useful for researchers, right?
Yeah.
You're not just getting a yes or no. You're getting the reasoning behind it and the papers to dig into further.
Definitely. That's much more helpful than just a black box answer.
All right. So the paper actually includes this really helpful diagram. Figure 1, it shows the CIBER architecture. And it builds a pretty standard RAG setup. You have your text embedding model, your vector database for storing all the knowledge, and of course the LLM itself.
Right, the usual suspects.
Yeah. But CIBER adds this extra layer on top. It's like a whole new component with 3 main modules.
3 modules. Okay, break it down for me.
So first, you have the multi-aspect interrogation, MAI. That's the part that generates those different probing questions, like, is this claim supported by the paper, or does the paper contradict this claim?
Right, right. That makes sense.
Then you have response resolution, or RR. This is basically a translator. It takes the LLM's answers, which can be all over the place, and turns them into a consistent format, like support, refute, or neutral.
Ah, so it standardizes the output, makes it easier to analyze.
Exactly. And finally, you have verdict and confidence, or VNC. That's where it takes all the standardized responses and combines them into a final decision. Like, overall, the evidence supports this claim, or the evidence refutes this claim, along with a confidence score.
Oh, that's really smart. So it's not just looking at individual responses, it's actually synthesizing the information from all those different probes.
Yeah, exactly. And the authors actually list these 3 modules and the overall CIBER framework as their main contributions, along with the specific methods they developed for combining the evidence and the creation of some new data sets for evaluating this kind of system.
Makes sense. Those are all valuable additions to the field.
All right, so let's step back a bit and talk about the history of all this. How did we get to CIBER? What were the stepping stones along the way?
Yeah, a little context is always helpful.
Right. So the paper talks about this evolution of retrieval-augmented generation. And, early on, the focus was really on improving the LLM itself, like training it on better data, making it more knowledgeable.
Okay, so basically making the LLM smarter from the get-go.
Yeah. But as LLMs got better at understanding context, the focus shifted to providing them with better external information, during the retrieval process.
So it's not just about what the LLM knows, it's also about how it accesses and uses external knowledge.
Exactly. So there were all these improvements in, source selection, query expansion, content indexing, ranking, and even iterative retrieval, where the LLM kind of refines its search based on the initial results.
Fascinating. So it's like the research was trying to make both the LLM and its information gathering process more effective.
Yeah. But the authors are very clear that CIBER is taking a different approach. It's not about improving the retrieval itself. It's about what happens after the information is retrieved. Like, how do we analyze the LLM's responses to really understand its level of certainty?
So it's not just about finding the right papers. It's about how the LLM interprets and evaluates those papers.
Right. And they also briefly mention other approaches to claim verification, where you might have separate steps for identifying claims, finding evidence, predicting a verdict, and generating a justification. But they emphasize that CIBER is specifically focused on the evidence retrieval and verdict prediction stages.
Yeah, so it's a very focused approach, tailored to this particular problem.
All right, so let's get into the nitty-gritty of how CIBER actually works. We already talked about the 3 modules, MAI, RR, and VNC. Let's start with MAI, multi-aspect interrogation.
Okay, back to the interrogation room.
Yeah. So the goal here is to really probe the LLM's understanding, to see if it's consistent in its evaluation of a claim when presented with different ways of asking about it.
Makes sense. So how do they actually construct these different probes?
All right, so they start with an original probe.
Yeah.
This is the most straightforward question, something like, based on this text, is the claim true? Very direct.
Okay, simple enough.
Then they create 2 other sets of probes, agree probes and conflict probes.
Agree and conflict. Okay, what's the difference?
So agree probes, or PAGs, are designed to elicit responses that should align with the original probe. They might be paraphrases of the original question, just worded slightly differently.
Got it. So if the LLM understands the claim and the evidence, it should give consistent answers to the original probe and the agree probes.
Exactly. Now, conflict probes, or PCFs, are designed to get responses that should contradict the original probe. They might ask if the claim is false according to the text, or if the paper refutes the claim.
Ah, so they're introducing some tension, some opposition to see if the LLM wavers in its assessment.
Yeah, exactly. And they consider variations in wording and sentence structure within each of these probe types, just to make sure they're really covering all the bases.
Thorough. I like it.
And to illustrate this whole process, they use the example of, the classic claim, human activities cause climate change.
Ah, yes. A good one for testing an LLM's scientific chops.
Right. So an original probe might be just that statement, followed by, is this supported by the paper? Simple and direct.
Okay.
A PEG probe might be something like, does the study described in this paper provide evidence that human activities lead to climate change?
So it's still asking about the same claim, but using different wording.
Right. And a PCF probe might be, according to this paper, is the claim that human activities cause climate change false? Or does this paper refute the claim that human activities cause climate change?
Okay, so those are clearly asking for a contradictory answer.
Yeah. And they experiment with various ways of phrasing these conflict probes. Like sometimes they use negation, sometimes they use different verbs, sometimes they rephrase the whole sentence just to, really test the LLM's ability to handle these subtle differences.
Fascinating. So after the LLM gets bombarded with all these questions, what happens next?
Right. So that's where response resolution comes in. RR, remember, this is the part that standardizes the LLM's answers because LLMs can be very creative in how they respond.
Yeah, they don't always follow instructions. Even if you ask for a simple yes or no, they might give you a whole paragraph.
That's right. So the researchers had to come up with ways to wrangle these diverse responses into a consistent format.
Okay, how do they do that?
So for one of the LLMs they used, GPT-2, which works by completing sentences, they actually added specific adverbs to the prompts, like relatively or quite, to try to guide the LLM to complete the sentence with words indicating a degree of support or refutation, like high or low.
Interesting. So they're kind of nudging the LLM towards a more quantifiable response.
Yeah, exactly. But for the more advanced models like GPT 3.5 and GPT 4, which are better at following instructions, they just told it to answer with yes, no, or I'm not sure.
Makes sense. Keep it simple.
But as we know, LLMs don't always listen. Sometimes they still give more detailed answers, even when asked for a simple yes or no. So they developed this whole system using keywords and patterns to map those varied responses back to the core categories, like support, refute, or neutral.
Ah, so they built a kind of decoder ring for LLM responses.
Yeah, exactly. For GPT-2, they would look at the words that followed those guiding adverbs. And for GPT 3.5 and 4, they would look for direct affirmative or negative statements or their synonyms.
Clever. So they're accounting for the LLM's tendency to be a little bit chatty.
All right, so now we've got all these standardized responses. What do we do with them? That's where the final module comes in. Verdict and confidence, V and C.
Okay, the moment of truth.
Right. So this is where CIBER takes all those responses from the multiple probes, considers the type of probe each one was, and tries to make a final decision, like, does the evidence support the claim or refute it? And how confident is it in that decision?
Makes sense. So it's like weighing all the evidence, right? Like a jury deliberating.
Yeah, kind of. But they actually explored 3 different mathematical approaches to do this.
3 different approaches. Okay, tell me more.
So one approach is called weighted proportions. It basically calculates weighted probabilities for support, refute, and neutral based on the frequency of each response type. But it gives more weight to the answers from the conflict probes.
Interesting. So a single refute response from a conflict probe might carry more weight than multiple support responses from agree probes.
Exactly. Because, a single piece of contradictory evidence can sometimes be more telling than a lot of supporting evidence.
Makes sense. What are the other approaches?
Okay, so the second one is called weighted information gain. This one uses concepts from information theory, like entropy, which is a measure of uncertainty, and information gain.
Okay, getting a little technical here.
Yeah, it is a bit more complex. But basically, it looks at how much each probe's answers reduce the overall uncertainty about the claim. And it weights those gains by the type of probe. So conflict probes, again, have a bigger potential impact.
Interesting. So it's not just about how many responses are support or refute. It's about how much those responses actually clarify the situation.
Exactly. And the third approach is called weighted belief update. This one uses Dempster-Shafer theory, which is a whole mathematical framework for combining evidence when there's uncertainty and even the possibility of conflicting evidence.
Wow, that sounds pretty intense.
It is, but the idea is that it can handle those tricky situations where the evidence might be pointing in different directions.
So it's like a more nuanced way of weighing the evidence, right? Taking into account the possibility of conflicting information.
Exactly. And they also tested a simpler approach, just taking a majority vote across all the individual probe responses, just to see how that stacked up against the fancier methods.
Makes sense. Always good to have a baseline for comparison.
All right, so they put CIBER to the test using a couple of different data sets. They created both synthetic data sets, where they had an LLM generate abstracts that either supported, refuted, or were neutral towards a claim, and real data sets based on actual scientific papers.
Oh, that's great. So they're testing it in both a controlled environment and a more realistic setting.
Yeah, and they specifically focused on 2 claims. Human activities cause climate change, and vaccines cause autism.
Ah, good choices. Very relevant and often debated.
Right, and they used 3 different LLMs. GPT-2, GPT 3.5 Turbo, and GPT-4 Turbo, just to see how CIBER performs with models of varying capabilities.
Makes sense. Got to test it across the board.
Yeah. And the results were really interesting. Across the different data sets and LLMs, CIBER consistently outperformed traditional RG.
That's impressive. So the multi-probe approach really does seem to make a difference.
Yeah. And the advantage was even more pronounced with the more advanced LLMs, GPT 3.5 and GPT-4. So it seems like CIBER really shines when it has a more powerful LLM to work with.
I can see why. The more nuanced the LLM, the more likely it is to reveal its uncertainties through these different probes.
Exactly. They also found that using only the conflict probes actually led to worse performance than using only the agree probes with GPT 3.5 and GPT-4. But this was reversed with GPT-2.
That's a curious discrepancy. Why do you think that happened?
Well, they think it might have to do with how the response resolution system was interpreting the answers from the more advanced models when they were asked those negative questions. Sometimes they would give extra context along with the yes or no, and the system might have misinterpreted those more nuanced responses.
So the LLM was being a little too helpful, and the system wasn't quite ready for that.
Yeah, basically. But they think with some improvements to the response resolution module, the conflict probes could become more effective.
Makes sense. There's always room for improvement.
But the main takeaway is that using both agree and conflict probes together, the full CIBER approach generally gave the best results. So, considering both confirming and potentially contradictory viewpoints is important.
Makes sense. It's like getting a second opinion, or even a third, to make sure you're not missing anything.
Right. They also compared the different evidence fusion strategies. Remember those 3 mathematical approaches. And they found that all 3 of them outperformed traditional RAG on their own.
Interesting. So no matter how you slice it, CIBER seems to be doing something right.
Yeah. But no single fusion strategy was consistently the best. And surprisingly, just taking a majority vote didn't really improve things. So there's still work to be done in figuring out the optimal way to combine all this evidence.
Definitely. Sound like there are some interesting research avenues there.
All right, so to sum it all up, CIBER is a really promising framework for making LLMs more reliable when it comes to verifying scientific claims. It uses this clever multi-probe approach to assess the LLM's certainty, and it's designed to work with a variety of LLMs and across different scientific fields. The results are really encouraging. It clearly outperforms traditional RAG, especially with those more advanced models.
Absolutely. This paper really highlights the importance of not just relying on an LLM's initial answer, but really digging deeper, probing its understanding from different angles.
Right. And the authors acknowledge that there's still room for improvement, in terms of response resolution and evidence fusion. But it's definitely a step in the right direction.
Yeah.
And they've actually made their data sets publicly available so other researchers can build on this work.
That's fantastic. Open science at its best.
All right, so for our novel notions segment today, we thought we'd brainstorm some potential future research directions based on this paper. And one idea that came to mind is, what if we could make the multi-aspect interrogation even smarter?
Oh, I like where this is going.
So instead of using a fixed set of probes, what if the system could actually learn which types of probes are most effective?
So it's like adapting its interrogation strategy on the fly.
Yeah, exactly. Based on the LLM's responses, it could figure out which probes are most likely to reveal inconsistencies or uncertainties.
That's really cool. It's almost like a scientist refining their experiments based on their initial observations.
Yeah, that's a great analogy. And maybe it could even use reinforcement learning to optimize its probing strategy, where it gets rewarded for finding those inconsistencies.
That's a fascinating idea, and it could be especially valuable in this really complex or controversial scientific areas where the evidence is more ambiguous.
Exactly. Another thought we had is, what if we could integrate CIBER with other types of knowledge sources, like scientific knowledge graphs?
Knowledge graphs. Oh, that's an interesting direction.
Yeah. So you know how CIBER focuses on analyzing textual evidence from papers? Well, knowledge graphs represent scientific entities and their relationships in a much more structured format.
Right. Like they show how different genes or proteins interact with each other.
Exactly. So if CIBER is evaluating a claim about, say, a specific gene interaction, it could also query a knowledge graph to see if that interaction is already known or if it contradicts existing knowledge.
So it's like checking the LLM's findings against a more established database of scientific knowledge.
Yeah. And any discrepancies there could be a red flag, prompting further investigation or lowering the confidence score.
That makes a lot of sense. It's like getting a second opinion from a different type of expert.
Exactly. And this kind of hybrid approach, combining the LLM's ability to understand natural language with the precision of knowledge graphs, could be really powerful in fields like biology or medicine, where there are these huge, well-curated knowledge bases.
Definitely. It would add another layer of verification, making the whole process even more robust.
All right, so those are just a couple of ideas, obviously. But it's clear that this paper opens up a lot of exciting possibilities for future research.
Absolutely. And it's great to see such innovative work being done in this area.
So the key takeaway for our listeners today is that CIBER is a really promising step forward in making LLMs more reliable for scientific claim verification. And it has the potential to really impact how we do science in the future.
Right. It's all about ensuring that our AI tools are not just generating text, but generating knowledge that we can actually trust.
Exactly. And we encourage all of you to think about the implications of this kind of technology. How might it change the way we conduct research, share scientific findings, and even combat misinformation?
It's a fascinating area, and one that deserves a lot more attention.
We've included a link to the full research paper in the show notes for those who want to dive in deeper. And as always, thanks for joining us on The Deep Dive.